So in this video, we're going to be looking at how to perform molar volume calculations. So going through worked solutions to Unit 8, worksheet number 1. So I've picked out 3 particular examples that we're going to work through in this video to talk you through how we can use the molar volume of a gas in stoichiometry calculations. So firstly, we picked example 4, which reads, when calcium carbonate is heated strongly, carbon dioxide gas is evolved. And we have the equation there. If 4.74 grams of calcium carbonate is heated, what volume of carbon dioxide gas would be produced when collected at standard temperature and pressure? Now just remember before we continue that standard temperature and pressure is 0 Celsius and 100 kilopascals. So just as with any BCA problem, any stoichiometry problem, we have to start with a balanced chemical equation. Now in this particular case it's given to us, so we're just going to pop that right into that usual spot. CaCO3 decomposes to form CaO and CO2, all with a 1-to-1 ratio. And so then we use the information that's given to us in the question to fill out our before line. But because we haven't started with moles, we need to do the mass to mole conversion to fill out that before line. So we work out the molar mass of calcium carbonate, and we end up with 100.09 grams for every 1 mole. And then we relate that with our 4.74 grams of mass to work out the moles of 0.0474 moles. So we put that in our before line for calcium carbonate, 0 for both of our products. And then because we are assuming, the principle is that all of that calcium carbonate is being used up so that we can fill out the column underneath the calcium carbonate to end up with 0. So then we look at our equation and our mole ratio to identify that the same number of moles is the moles of our calcium carbonate is also the moles of our carbon dioxide. So we can pop that into our table and also for calcium oxide. So we would end up with the same number of moles of CO2 as calcium carbonate that we started with. So with that in mind then, we can use our molar volume of a gas, remember that applies to any gas, to work out the volume in litres that would take up. And so we can recognise that 1.08 litres of carbon dioxide will form. For the next example, we go to question 6, where we consider the following reaction. Between P4 plus 6H2 forms 4PH3. What mass of P4 will completely react with 2.50 litres of hydrogen gas at 0 Celsius and 100 kilopascals? So, as always, we start with a balanced chemical equation. Again, it's given to us, so it's very easy for us to put it in there. Okay, then we look at the information that's given to us in the question to fill out our before line. Now in this case, we're not given a mass value, we're given a volume value in terms of the volume of the gas. So in order to work out how many moles that we have, we're going to need to use our molar volume. So we work out that the moles by 2.50 litres multiplied by 1 mole over 22.71 litres to give us a value of 0.11 moles. Now, just as before, the ... signifies that there are more decimal places that we're not writing, but they would be kept in our calculator as we work through the process. So we can use this information to fill out, the before line of our BCA table. Now we're assuming that there is an excess of P4. We will be working out the mass that will be changing there, or the moles that would be changing, but for this case we can put in excess and as always 0 for our product. And we are assuming that all of that hydrogen gas will completely react because the question proposes that, so we end up with 0 moles. So now we have to use the mole ratio in our equation to identify how many moles of P4 will be involved. So we can look at the moles of hydrogen that we've got and our 1 to 6 mole ratio using our factor of 1 to 6 that we've written over here to work out that our moles of P4 is 0.018. Again, with more decimal places that we're not writing. So we can drop that in there. We can also use the same ratio of either 1 to 4 from P4 to PH3 or 6 to 4 from H2 to PH3 to work out how many moles of PH3 are being formed for completeness. But in this particular question, we don't actually have to work that out. So now we then have to do the mass to mole conversion, saying, all right, if a certain number of moles of P4 have reacted, what mass would that translate into? And using its molar mass, taking the value of phosphorus, multiplying it by 4 because that's what the molecule is, and then to identify that 2.23 grams of P4 would be required. And now we move on to question number 8, our last example from this sheet. Nitrogen gas and hydrogen gas combine to produce ammonia gas, which is NH3. What volume of hydrogen gas at STP, that is 0 Celsius and 100 kilopascals, is required for the complete reaction of 10 grams of nitrogen? Now, in this case, we're not provided with a balanced chemical equation, so you need to construct it. So we have N2 plus 3H2 goes to 2NH3, so a 1 to 3 to 2 mole ratio. Now we have to go with the information that's given to us in the question, which is the 10 grams of nitrogen as its mass. So we need to perform the conversion to convert from mass to moles for nitrogen first. So we multiply 10 grams by 1 mole over the molar mass. Now just remember, because it's N2, we have to do 2 lots of the nitrogen in our molar mass to work out 0.357 moles without additional decimal places. So we can fill out the before line of our table. We're assuming an excess of hydrogen gas, and that we're also making the claim that all of the nitrogen is completely reacted. That's what the question is asking, and 0 for our product. We can use the mole ratio of 3 to 1 to convert the number of moles of hydrogen into the moles of nitrogen into the moles of hydrogen to work out 1.07 moles. And so now we can complete that section of the table, and we can also use the mole ratio of 1 to 2 to fill out the section under the ammonia for completeness. But for this particular question, we aren't being asked to calculate that value. But so now, knowing how many moles of gas would be required for that complete reaction, we can use our molar volume of a gas to work out what volume of gas is required. 24.3 litres of hydrogen gas will be required, and that's at 3 significant figures. Okay, so that's the wrap up of going through these 3 examples. Thanks for watching.